Alrighty then. This is the last section basically in Unit 5 other than your AP style question review. But let's kind of get moving. So this is inverse trig integration. We want to basically integrate all of these different functions that are inverse trig functions. So if we have the integral of du over the square root of a squared minus u squared, so this is the same as saying it's really the arc sine of u divided by a plus some c. Now there's a proof we can do with this. I'm not going to show it to you, but we can figure it out if you really want to. You can talk to it in class. It's not a big deal. The second one, this is because it's no square roots, right? It's going to have to be a tangent. So in order to get tangent, it's going to be 1 over a times the arc tangent. I meant to do little lowercase a, but I didn't. Times the arc tangent of u over a plus some c. And then the last one there, there's no absolute value, but I mean, we can think of it like there being one, so we know that's going to be secant, right? So it's 1 over a times the arc secant of u over a plus some c. Okay, now, we don't really need to think about, like, these are the only three we need to worry about. We don't need to worry about any negative ones, because remember the negatives are arc cosine, arc cotangent, arc cosecant. But because the negative with integration gets pulled out in front of the integral symbol, right, it gets, so this is negative here, right? So this negative, say, gets pulled out. Then I integrate this like I would normally, which is arc all of this. But then the negative just means this is negative. So instead of it being negative arc cotangent, right, I can just, or instead of it being cotangent, the negative is the same. It means the same thing in this case. So you don't have to worry about any of the cosine, cosecant, cotangent ones here. It makes life a little nicer. Okay, first one here. We got to recognize which one this is. Hopefully remember that this is probably going to be our sine. All right, so we're going to say, okay, u is going to be x. Du is going to just be dx, right? And so that makes it easier. In this case, a is 2 because I want to square root basically all of this stuff, right? I want it to be a squared minus u squared. Okay, so that's got to be a 2. Think about that. So this is really the integral of du over a squared minus u squared, okay, which is the same as the arc sine of u over a plus c. But in this case, u is x and a is 2 plus c. Okay, so that's kind of one way to do it here. This is going to look a little weirder because the 2 is kind of playing funny tricks on us there. Okay, so I want this to be du over a squared plus u squared, right? So that's arc tangent. Okay, so u is going to be equal to 3x. So it's u squared. So this is 3x. Du is equal to 3 dx. So dx is equal to 1 over 3 du. All right, so that 1/3 is going to get pulled out, very similarly to how the formula actually is, right? And so then, in this case, a is equal to the square root of 2, and let's do it now. We get the 4 gets pulled out, and it automatically gets pulled out, over 3, that was the 1/3 that I pulled out, times the arc tangent of u over a plus c. So I get 4/3 times the arc tangent of u is 3x over a, which is the square root of 2 plus c. Okay. Oh, I'm sorry. And then, shoot, I forgot to do this properly. Arc tangent was 1 over a times that. So a is 1 over root 2. Shoot, my fault. 4 over 3 root 2. I forgot that root 2. That's so important. I'm just kidding. You might not see like one of these on the BC test. Probably none. You probably won't see any of these. You think you saw one on the AP test. Okay. Number 3 there. Hopefully we can see that this is going to be arc secant And so in this case, I want u to be 2x. Du is equal to 2 dx, so dx is equal to du over 2. All right, a is equal to 3, okay, because this is our square root of that is 3. What else do we need? We need x. We got to solve this again. So what's going to happen is if I plug this in, okay, if I plug this in, I'm going to get du over x square root of u squared minus a squared. Okay, with that this 1/2 is being pulled out. But this x has got to get like canceled, so we're going to substitute back in. And so if I solve that, I get u is equal to u, or x is equal to u over 2. So we're going to take this u away. Okay, let's take that u away. And then we're going to replace it with u over 2. Okay, but what's going to happen? Well, that's actually going to come out as a 2, not a 1/2, because I'm really dividing by it, so it's got to multiply by the reciprocal. So that is actually going to cancel with that. So this is equal to, so it's going to cancel, equal to du over u root u squared minus a squared. So that is equal to 1 over a arc secant of u over a plus c. So that's 1 over 3 times the arc secant of u, which is 2x, over a, which is 3, plus some c. Yeah. Okay, integration by substitution. Too bad we already did integration by substitution. Pretty much all the ones up top. Haha. Okay, so in this case, let's go and we'll say u is equal to e to the x, because I want it to be squared, right? So what's the square root of e to the 2x? E to the x. Du is equal to e to the x dx, and dx is equal to du over e to the x. Okay, great. A in this case is equal to 1, because that's going to go right there. So what do we get? We get the integral of du, okay, is equal to that. So dx is equal to du over e to the x. So I get du over e to the x over the square root of u squared minus a squared. Okay? So now what happens? Well, let's kind of reevaluate this a little bit, and I'm going to get du over e to the x root u squared minus a squared. But what is e to the x? Well, e to the x is u. So I'm going to take away that e to the x. Okay, take away that e to the x. I'm going to put a u there. So in this case, what does it look like? It looks like arc cosecant, right? I'm sorry, arc secant. So it's 1 over a times arc secant. I'm going to use that negative 1 power now, of u over a plus some c. So it's 1 over 1 times the secant of inverse of u, which is e to the x, over a, which is 1, plus c. So answer is arc secant of just e to the x plus c. There we go. That's not too bad. Next one is x plus 2, integral of x plus 2 over square root of 4 minus x squared. So what I'm going to do now, to make it a little easier on myself, because the denominator is a monomial and the numerator is a binomial, I'm going to split the integral. So this is the same integral of x over square root of 4 minus x squared dx plus, and then I'm going to pull that 2 out, times the integral of 1 over square root of 4 minus x squared dx. Okay, so I'm going to make that change. It's the same thing, I just split the integral up. In this case, I'm going to make u is equal to 4 minus x squared, du is equal to negative 2x dx, and dx is equal to du over negative 2x. So if you think about it, this x and this x are going to cancel. The negative 1/2 is going to get pulled out front. And so this is going to be the negative 1/2 of the integral 1 over the square root of u, okay, which is equal to, let's do one more, the u to the negative 1/2, okay, du. Hopefully we can see that. You can see what's going on. The reason I did not change this into some sort of arc secant, arc cosine, arc, any of that garbage, was because I had an x on top, and if I took u substitution with the denominator, I can definitely change it. So like in this one here, okay, if I turn, we'll do this one example, okay, real quick here. If I made u 4 minus x squared, and then du was just negative 2x dx, and then therefore dx is negative du over 2x. Like there's nothing to cancel with that x, right? So this would be plus 2 root, or integral, and then I would get negative du over, well actually this 2 would come out, so this 2 would actually turn into a 1, so 2 divided by 2 is a 1, and this would be x root the square root of u, okay? And then I can, okay, if we wanted to solve for that x, right, you would get, this is u plus 4 square rooted, so this would be the integral of negative du over the square root of u plus 4 times the square root of u. And that doesn't help anybody. That doesn't help anybody. So that's not very good, right? Because that would give you square root of u squared plus 4u. And that puts us in the same boat as right back here. Like, it's still crazy to do. So that's why I didn't do something like that over here. I didn't make u, or 4 minus x squared is my u. But I didn't make, and it turned into arcsecant on the left side because I was able to cancel out that u. Once you're able to cancel that u out, like, and that x out, like, it makes sense, right? It's pretty self-explanatory there. So I'm going to make this case. I've already used u's over here, so I'm going to use v's over here. So v is equal to just x, okay? And then dv is equal to just dx. And then our a is 2, so the square root of 4 is 2, okay? So I can see that this is really plus 2 times the integral of dv over the square root of a squared minus b squared. Now I can integrate this, okay? Hopefully you remember how to integrate that. You add 1, divide by that power, so it's negative a half times 1 half times u to the 1 half, okay? Divide by, oh, I got to divide by the 1 half, which actually turns it into a positive 2. So I made that mistake. That's actually a positive 2 there. So that's times 2 plus 2. Now this is your arc sine. So 2 arc sine of a, or v over a. V is x over a was 2. All right, and that is plus some c. But in this case, we get negative. Actually, just negative 1. Negative u, what's u? If I go back here, 4 minus x squared. And that's square rooted, right? Plus 2 times sine inverse of x over 2 plus some c. So that's really a little bit complicated. You want any, I doubt you get anything like that on the AP test. You guys took it once, you probably already know, but you know, you never know. Live and learn, right? We got 2 more problems. I really don't want to do 2 more problems. I am I'm gonna call it a video. I don't think we need to know the last 2. I think they're good if maybe this is all on the test, but I don't really want to waste another 10 minutes on these 2 problems when you're probably never going to see them again, honestly. So if you want to know how to do them, they're in your notes, but on Power School. But for now, I'm going to cancel this video and call it a day.